Juan Santiago is the Charles Lee Powell Foundation Professor of Mechanical Engineering at Stanford. His research includes on-chip bioassays and capacitive deionization. He is a fellow of 3 societies, the APS, the ASME, and the AIMBE, which is a bioengineering society. He has published 200 journal papers and is highly cited with an H index of 80. He has 60 patents, 26 of which are licensed. Juan, let's hand it right to you.
All right, yeah, thanks very much. And welcome everyone. I see the number of participants is still growing. People are still joining, but we're all very excited to have you. Yeah, like Jesse said, my name is Juan Santiago. This is a webinar where we're celebrating the launch of a new journal, a journal called Flow by Cambridge University Press. And what I'd like to do is first take a few minutes to introduce you to the journal and try to convince you why you should consider submitting papers here, submitting your best work here. So let me go on. I'm going to share a couple of slides and get started. So this is just an informal type brainstorming type session result of some discussions we've had among the editors of this new journal, and basically reflecting on all the widely different and myriad applications of fluid mechanics. And what we've done is sort of arranged it. So on the left is the engineering and devices, creation of systems, things to try to benefit and improve the lot of human society. On the right is understanding and using fluid mechanics as a tool to understand nature. Both the physical world could be all the way to astrophysics, or it could be the microscopic world in biology. And the reason we've arranged it this way is to try to emphasize that our new journal aspires to embrace all of this, okay? So we want to have papers both on the engineering side, on the device and technology creation, but also on the basic science inferences and insight into nature. And all of that we call applications of fluid mechanics to each of these subjects. The next thing I want to tell you about this is that, about the journal, is that we're very proud of the fact that Flow is a sister journal. It's a companion journal to JFM. We benefit from the fact that JFM has, well, first of all, such a good reputation, but also a very wide and deep list of fluid mechanics reviewers. So one of the reasons to submit to Flow is that we can leverage this large database and this experience from JFM to get you good reviews on your paper, on the fluid mechanics aspects of your paper. And then for each paper, we then have to seek out, and we'll continue to do this, seek out also reviewers in the specialized topic. But the fluid mechanics, we think we have handled, and because of this partnership with JFM. Here, I've just created a few slides. So the journal is up and running. We have now published the first few set of papers. The journal has no issues. There are volumes, so we're now in the first volume, but we publish papers, open access, put them on the internet as soon as they are reviewed and as soon as they're ready. So as soon as they go through review, you'll be able to go. You don't have to wait until we bundle certain papers together into an issue. It's first come, first serve in terms of the publication. And these are just a few examples. On the top right is a study on basically reduced order model around vertical axis turbines. This is from a group at the University of Manchester as well as École Polytechnique. And what we're showing here is a couple of schematics and this reduced order model to be able to place turbines and see their wake interaction. On the left is a group from Caltech with a senior author, John DeBeery, who looked at inferences of things as simple as looking at a flagpole or a tree and inferring wind speed from that. And they have measurements in wind tunnels, but they also have sort of field measurements like this little tree in a parking lot, subject to deformation from the wind. And on the bottom right is from the lab of Moran Berkovich at Technion University in Israel, where they look at, or they've been able to suspend liquids in immersed in other fluids, other immiscible fluids, to create very large, high quality lenses with very smooth surfaces. And we just found out that Moran's paper Moran's work and this experiment has been chosen to go to the space station. And so it'll be an experiment in an upcoming mission in the space station. Okay, so this is sort of a broad overview. On the right, I list our associate editors and advisory board. We're very proud of both of these. Our editors cover a very wide range of technologies, from colloids and complex flows to numerical analyses, to aerodynamics, to microfluidics, to heat transfer and multi-phase flow, all the way to swimming and microorganism interaction and atmospheric turbulence. Our advisory board I list here, but I think you may recognize many of the names. And we actually have two of the speakers today are in our advisory board. So I'll just take maybe 1 or 2 more minutes. So why submit to Flow? Flow's an open access journal. It's shorter format than, say, JFM, and we believe it offers a very wide scope. So a reason for you to publish is if you're trying your work to reach a much wider audience, not just your specialty field, but anyone interested in the applications of fluid flow. We benefit, of course, I've already mentioned this, from our partnership with JFM for high quality reviews. And we hope also to be able to disseminate methods and tools, experimental tools or numerical methods, for example, across many fields. So things like shock capture might actually be useful in microfluidics, and that's actually true. We've done that as well. And lastly, we hope to offer, or we are already offering, fast turnaround reviews and high quality editors. We have a few article types, but I'll let you read the website for that. We'll put a couple of links in the chat to remind you how to get to our journal. So let me get to today's webinar. Today's webinar, we picked specifically speakers who are leaders in their field and who represent the very wide and myriad applications of fluid mechanics. So we're going to have all the way from planet level climate science to microorganisms. That's the first 2 talks. We're going to go all the way to magnetohydrodynamics of the sun in Mark Mish's talk. Lydia Boruba, sorry, I always mess up your name, Lydia. So Lydia Boruba, sorry. Okay, there we go. It's getting closer. Will talk to us about the fluid mechanics of breathing and disease transmission associated with that. Parviz Moin will talk about jet planes and aerodynamics of full-scale simulations around jet planes. Charles Baroud, who you may know as a microfluidics expert, is going to be talking about droplets in microfluidic assays in droplets.